Greetings and humble salutations. My name is Anthony Diaz Enriquez, and I am a senior biological systems engineering undergrad at Florida A&M University with a concentration in natural resource conservation. And today I'll be discussing the principal component analysis of land use for the southeastern states of the United States. A little bit of background: the Economic Research Service reports a major use of land in the United States every 5 years. And every state has a varying amount of acreage within the different types of land use. For this research, crops, forests, grassland, and special use were the four that were used for to conduct the research. The data was taken for the year 2012 to conduct the PCA analysis, and this analysis would compare the variability for the four types of land uses of every state. So the question is, can PCA analysis be used to find any correlation between the many land uses in every state for the year 2012? So the data was taken and placed in an Excel sheet prepared by specifying the land types of every state, and that data was then placed in Excel statistic to run the PCA analysis for the year 2012. And the results were compared based on the summary statistics, correlation circle, and the observation table, which we will see in a moment. This chart shows the states that were used to conduct the research, from Arkansas to West Virginia, and highlighting the total acreage for each land use, which is crop, forest, special use, and grasslands. This is the summary statistics, which basically gives a minimum, maximum, mean, and standard deviation of the total amount of acreage for each land use. And here is the correlation circle and the observation table. Essentially, what PCA does is takes the line of data and turns them into dimensions in order to observe them through the correlation circle. Each dimension shows a certain amount of data. So for example, in this case, F2 shows 28% of the data, and F1 shows 39% of the data. And since we are observing four different land uses, F1 and F2 are the best dimensions to analyze the data. Correlations are based on the angles between the lines. So a positive correlation is a narrow angle. Direct correlation is the same line. A negative correlation is if two lines create an obtuse angle, and no correlation is obtained when two lines create a 90-degree angle. So as we can see, the forest and special use share the same line. So there is a direct correlation. But when compared to crops, the croplands, there is no correlation because there is a 90-degree angle. But we can see that there is a positive correlation for the grasslands, and crop is more positive compared to the forest, special use, and grasslands. And the observation table on the right gives you the same data, but essentially gives you more with showing the acreage of all the states. So on the left-hand side, there's less data, or I'm sorry, less acreage, and farther right, there's more acreage. So in conclusion, based on the chart, there are direct correlations with the forest and special use in all states. The chart also indicates that there is a positive correlation between the croplands and grasslands, but no correlation between the croplands and forest and special use. This highlights how PCA analysis can be used to observe correlations between many land uses in different states. And this builds a framework for further research with more quantitative variables, such as more land use variations and multiple years, and et cetera. These are my acknowledgements, and I'd like to thank the USDA and NEFA and my research advisor, Dr. Nandi, and Mr. Ryanese for the support in completing this research. Thank you, and it's been an honor to present at the 93rd NTA conference.